Okay, so welcome everybody to this presentation. This presentation is basically the result of a series of debates, right? Debates have been going on for a long, long time about the impact of stretching on performance in football, right? Different kinds of stretching, static stretching, dynamic stretching, different aspects of performance in football, speed, agility, coordination, injury prevention, right? So this debate has been raging. There have been many studies and analysis done about it. We decided to conduct our own study here at Excelsior Football Academy. Now this study was analyzing the impact of dynamic stretching on the sprinting speed of pre-adolescent male footballers. Okay? Because we used the under 13 team of Excelsior Football Academy. All of the participants gave their consent to be involved in this study, as did their parents. Okay? Let's just talk a little bit about the subjects before we get into it. The subjects were all pre-adolescent boys with a mean age of 11.7, standard deviation of about half a year. Okay? So all in between 11 and 12 years old, right? Average weight was 52.7 kilos, okay, with a standard deviation of about 10 kilograms. So you had different weights, but all within about 10 kilos. Average height was 159.7, so about 160 centimeters. They were of different heights. You can see the standard deviation is quite high, about 20 centimeters. But I guess that's common in boys of that age, and I don't think it will affect the results of the study. Training age was 1.5 years, so about a year and a half they'd all been training with us at Excelsior Football Academy. Some maybe a little less, some a little more. Our standard deviation is there, 0.7. 5.5 hours a week, okay? So 3 1.5 hour sessions a week. So pretty average fitness, I would say. Let's go right into it. The methods that we used to conduct this study were very simple, actually, very straightforward. We had 2 lines of cones. You can see one here, as well as one over here. This line of cones was the 20-meter sprint. 20-meter sprinting line right there. Okay. Now all of the subjects had to conduct 2 sprints. The first sprint that they had to conduct was without any stretching before the sprint. Okay, no stretching involved. The second sprint was after they completed their first sprint, they would conduct a bunch of dynamic stretches right here on the second line for about 5 minutes, for exactly 5 minutes actually. Then they would go and repeat the 20-meter sprint. Alright? So that's basically how it worked. 1 20-meter sprint, 5 minutes of dynamic stretching, and then another sprint. 20 meters also. Okay, we timed the sprinting. This was a dynamic stretching protocol, very basic dynamic stretching protocols for that age. Jogging backwards, skipping and swinging, a sideways shuffle, high knees, all of these things are right here. Okay? So I would say you're pretty average dynamic stretches for that age group. Okay? The materials that were used in order to measure out 20 meters, we used the Stanley Tylon measuring tape. Okay, the model make is there. And this was a stopwatch that was used to time the sprint speed of the athletes. Okay, very basic stopwatch, very simple, not complicated. Okay? Let's just dive right into the results. Okay? As you can, I don't know if this is very clear, but as you can see, the blue line indicates the time of the first sprint, and the red line indicates the time of the second sprint. Alright? So as you can see, in most of the subjects, time decreased in the second sprint, which means that post the dynamic stretching, their 20-meter sprint time went down. Okay? It might be a little clearer with this. As you can see, first sprint, second sprint, difference. Alright, so in almost every single one of the cases there, as you can just look at your differences there, almost all of them had a decrease in sprint times, which means an increase in speed. Alright, so that's interesting. Alright, 2 of them had a very slight increase in sprint time during the second sprint. And we're going to talk a little bit more about that later and why that was. Here's your average. Your average time for the first sprint among the athletes was just over 4 seconds, 4.04 seconds, with a standard deviation of a fourth of a second. Okay? The average time of the second sprint, 3.85 seconds. Okay, with a standard deviation of 0.21. The mean difference there, as you can see, is 0.19 seconds. So that's considerable. For a 20-meter sprint, that's not bad. Again, standard deviations are all very similar for all three of these. Okay, so basically, they conducted their first sprint, they did their dynamic stretching, and then they conducted their second sprint. And in 80% of the cases, the second sprint was faster. Okay, that's the discussion. Let's talk about that. Results would seem to indicate the dynamic stretching has an enhancing impact on sprinting speed, right? If we look at these results here, it's pretty clear the mean difference there is faster after some dynamic stretching, okay? There are other studies that have been done in this area that seem to back up our claim or our conclusion. Okay, Little and Williams in 2006 tested the impact of differential warm-up protocols on high-speed motor capacities of professional soccer players in the English Premier League, and they found that dynamic stretching was the most effective form of stretching for football. Okay, the motor speed, high-speed motor capacities of football players, and that's at the professional level. But still, the studies seem to indicate that dynamic stretching increases speed in footballers. Okay, Fletcher and Jones in 2004 conducted a study where various stretching protocols were tested for impact on 20-meter sprint. So this was very similar to our test. Okay, 20-meter sprint performance of rugby union players. So different athletes, of course, at the professional level, but still more specific to what we're trying to test, the 20-meter sprint times. Right? The results show a decrease of sprint time of about 0.05 seconds after active dynamic stretching. So in their study also, sprint timings were decreased, or we could say speed was increased after a series of dynamic stretches. Okay? Why is that? So that's the question. If it does increase speed, or at least short-term 20-meter sprint speed, why? Okay? Dynamic stretching, and this is a study by Prentice and Sherlock in 1985. It says dynamic stretching causes an increase in temperature in the core of the muscles. Okay? Now, an increase in core temperature of the muscles causes an increase in the sensitivity of the nerve receptors and increase in speed of nerve impulses, encouraging muscle contractions to be more rapid and forceful. Okay? So when you're doing dynamic stretching, what you're really doing is you're warming up various muscles in your body. And when those muscles are warm, then the contractions of the muscles and muscle nerve impulses are more rapid and more forceful, which means you can increase your speed. Okay? That's very likely the reason why. Dynamic stretching seems to increase speed in footballers. Okay? Some questions to ask. Why the difference in the rate of increase for each player, right? If you go back here, we can see some players, the difference was huge. Like, for example, if we look at subject number 7 over here, almost a full second, 0.62 seconds increase. Up here, we see the difference very small. Okay? Why is that? Well, we don't know, actually, right now. The other question to ask is why the decrease of speed of 2 out of 10 players? Right? So we saw that earlier. In 2 out of 10 players, subject number 5 and subject number 6 over here, 0.03 and 0.09 seconds increase for their second sprint. Why is that? Okay? I don't have scientific data to explain why. Okay? I just have some possible reasons. Okay? Possible reasons could be a lack of mental focus during the second sprint. Alright? In 11 and 12-year-old boys, sometimes their focus and concentration goes up and down. So it could have been that. Varying technical quality and body movement during the sprint. Okay? Could have been, just different kind of running. They weren't really focused. Possible fatigue. That's a possible reason. I don't think so, because The players had been training quite regularly, so I don't think 20-yard sprinting would have fatigued them at all. Another possible reason is the inexactness of pressing the stopwatch manually. It was a manual timing method, right? Go, when they reached 20 yards, we press the stopwatch. And with these sort of marginal timings that we're talking about here, very, very marginal, it could have been even the amount of time it took for us to press the button on the stopwatch. Okay, so just some things to think about. Right? So those are your possible reasons. Conclusion, in most cases, according to our study and other studies, dynamic stretching appears to increase the immediate sprinting speed of young male athletes if performed immediately prior to sprinting. Okay? Immediately prior to dynamic stretching. Okay? Further study is needed to discover why exactly it does so and why it seems to have a greater impact on some athletes than others. Right? So like we saw there, we don't really know why. In some athletes it has a greater impact on their sprint speed, and in some athletes it doesn't have any impact, or a marginal impact. Why? I don't know. We might need further studies to look at that. Okay? Practical application. This study suggests that coaches and trainers may use dynamic stretching as a means of enhancing the temporary sprinting speed of young male athletes. Okay? Other studies show that not just for young male athletes, that dynamic stretching impacts the sprinting speed of all athletes. But we can't verify that because our study was only for 11 and 12-year-old boys. Okay? So that's the practical applications that it has. Thank you so much for listening, for coming here today, being a part of this. Hope to see you soon. Thank you for your attention. Have a good day.